This is part 2 of the Chapter 6 lecture notes, and we were covering the checkpoint questions and had gotten down here to question number 6. If the activity of osteoclast exceeds that of osteoblast, how will the mass of the bone be affected? Since osteoclast are breaking down bone tissue and osteoblast are building new bone tissue, then the mass of the bone is going to be decreased if this happens. Okay, so bone formation. There are two types of bone formation. Embryonic development of bone begins at week 6 as a cartilaginous formation. You probably know that babies and small children have more cartilage than adults do. And then that cartilage is replaced with bone, and that process is called ossification. There are two types: intramembranous ossification, which is what happens with bones, for example, like the skull bones, and then endochondral ossification, which is what happens with long bones. Now, another process that occurs during ossification is calcification, and that is the forming of that calcium phosphate ground substance. Okay, so intramembranous ossification starts with week 6, and basically it's defined as bone develops within sheets of fibrous connective tissue. The development of the bone begins in an ossification center. Bone cells called osteoblasts differentiate or specialize from connective tissue stem cells. The bone matrix formation extends outward from that ossification center. Blood vessels come in and infiltrate the bone, grow into the area, and are trapped within the developing bone. And most of the bone that forms is cancellous or spongy bone. So examples of bone that form this way are the bones of the skull, the jaw bone called the mandible. These are bones that form by intramembranous ossification. Then we have endochondral ossification, which is a little more complex, and there are several steps involved. And this is the formation for most of the bones of the skeleton. We tend to use the example of a typical long bone when going through the steps. And what happens is that a cartilage model is replaced by true bone. So the entire bone starts out as a cartilage model. And you can see here in step 1, you have a hyaline cartilage model of a long bone. And the first thing that happens is chondrocytes, or cartilage cells, enlarge and then die. They actually enlarge or hypertrophy, and then they die. And then in step 2, osteoblasts cover the shaft of the cartilage in a thin layer of bone. You see that thin layer here and here. And then in step 3, the blood vessels penetrate the cartilage and enter into the bone tissue. A primary ossification center forms in the shaft of the bone. And what happens is bone tissue forms there and replaces the cartilage. And it's spongy bone tissue that's forming to begin with. Step 4, the bone of the shaft thickens and the cartilage near each epiphysis is replaced by shafts of bone. So we have the bone is growing longer and wider, and the marrow cavity is also growing wider. And bone is replacing cartilage at the epiphyseal plate, or what we call the epiphyseal cartilage. So in step 5, blood vessels invade the epiphyses and osteoblasts form secondary centers of ossification. So this would be the primary center of ossification, or primary ossification center, that forms in step 3, and that forms in the shaft of the bone. And the secondary centers form in step 5, and they form in the epiphyses. Some of the cartilage does not get replaced by bone. It remains on the ends, and it becomes what we call articular cartilage. So these are the steps of endochondral ossification. I recommend that you read through them and learn the order of the steps. but we do need to move on. So let's talk about the epiphyseal cartilage is what we have there. You've also heard me call that the epiphyseal plate. And that's what we have between the diaphysis and each epiphysis as the bone is growing. At puberty, the bone growth accelerates due to increased sex hormone production. So these increased sex hormones cause bone growth to accelerate. That's when you'll see a growth spurt. The osteoblasts are producing bone faster than the epiphyseal cartilage can grow and expand. So finally, you have an epiphyseal line that is left. And once that happens, once that the epiphyseal cartilage is closed and the epiphyseal line forms, then that is adult bone. When the bones get wider or they grow in diameter, we call that appositional growth. And two things are happening. Osteoblasts are producing bone on the outer surface, and osteoblasts are removing bone tissue from the inner surface. So that allows the marrow cavity to enlarge. And here's a picture of appositional bone growth, how bones grow in diameter. The timing of the epiphyseal closure varies from bone to bone. The digits close early, the arm, leg, and pelvis bones close later. It also varies from person to person. There's different timing in males versus females, and most of this is due to differences in sex hormones. Males do have a later closure than females do. The requirements for bone growth, well, you have to have minerals, calcium and phosphate. And these minerals are absorbed from the mother's bloodstream during prenatal development while she is pregnant. And then vitamin D3 is very important, plays a role in calcium metabolism. What happens is the liver and the kidney process vitamin D3 into a hormone called calcitriol. And calcitriol stimulates calcium and phosphate absorption. So another way to say this is that you need vitamin D3 in order to absorb calcium and phosphate into your blood. So no matter how much calcium you get in your diet, you need the vitamin D3 to actually make use of it. Your skin manufactures vitamin D3 when it's exposed to ultraviolet radiation, but it does not take a whole lot. I think they say 15 minutes a day of sunlight exposure is enough, unless you get older, and women especially as we get older may need to actually have vitamin D3 supplements, but that is something that you should discuss with your doctor. Deficiency of vitamin D3 leads to the softening of bones, and in adults this is called osteomalacia. In children it's called rickets. Vitamins A and C are also important for bone growth. They provide support for osteoblast. And then various hormones, growth hormone, thyroid hormone, the sex hormones like estrogen and testosterone, and then the calcium balancing hormones, PTH and calcitonin. PTH stands for parathyroid hormone. Let me write that for you. P-A-R-A. Thyroid hormone. Thyroid. Sorry, but anyway, it's parathyroid hormone, and calcitonin is the other calcium balancing hormone. PTH or parathyroid hormone is produced from the parathyroid glands. Calcitonin is produced by the thyroid gland, and they help to regulate the calcium balance in your blood. Okay, checkpoint. During intramembranous ossification, which type of tissue is replaced by bone? It's connective tissue. How could x-rays of the femur be used to determine if a person had reached full height? We would look for the presence of an epiphyseal line. A child who enters puberty several years later than the average is generally taller than average as an adult. Why? And that is because growth is going to occur until puberty, and then after puberty, growth is going to continue to occur. So that only makes sense that the person's going to be allowed to grow for a longer period of time. Why are pregnant women given calcium supplements and encouraged to drink milk, even though their skeletons are fully formed? And that is because they are losing calcium to their baby. They're during pregnancy, the calcium is taken from the mother and given to the baby, basically. Remodeling is a process that recycles and renews bone, and this occurs in all of us throughout our lives. Bone looks like, when you look at a bone, it looks like, that it doesn't change, but it's actually constantly being remodeled, broken down, rebuilt, all of that. So again, going back to the cells, osteocytes maintain the bone matrix, osteoclasts remove matrix, osteoblasts build matrix, and this process is called remodeling. Regular exercise is important to maintaining bone structure. Weight-bearing exercise actually helps to build more bone tissue. In young adults, nearly 1/5 of the skeleton is recycled and replaced each year. So remember, we talked about the skin. It takes about 3 weeks to replace one skin cell, for one skin cell to be produced and then shed, basically. So it takes about 5 years to remodel the entire skeleton. The skeleton is a calcium reserve. 99% of the calcium is deposited in the skeleton, in the bones. It's an essential mineral for nerve cell function and muscle cell function. So conducting nerve impulses and muscle contractions. All right, let's look back down here at the bottom at our regulating calcium ion balance in the blood. Parathyroid hormone and calcitriol raise blood calcium levels. So they're going to cause calcium to be moved from the bone into the blood. Calcitonin, which is produced by the thyroid gland, lowers blood calcium levels. So let's talk about this again. It's an example of negative feedback in the body. Parathyroid hormone produced by the parathyroid gland, and calcitriol, which is converted from vitamin D3 by the liver and the kidney. Let me make sure I said that right. Yeah, I knew it was, but you know how sometimes you just forget things, and so the calcitriol is converted from vitamin D3 into calcitriol, and that happens in the liver and the kidneys. And this hormone and PTH help to raise blood calcium levels. But if the calcium levels in the blood are too high, calcitonin, which is produced from the thyroid gland, will lower those blood calcium levels and move that calcium into bone tissue so it can be stored. There's a section on bone fractures. The two main categories are closed and open fractures. Open fractures project through the skin. This is a list of the steps that are required to repair fractures. The large blood clot that stops the bleeding is called a fracture hematoma, and that's going to form. And I'll just leave you to read the rest of the steps and go through the rest of the steps. We're not going to have a lot of questions about that. Let's go back to number 12 and 13. 12, why would you expect the arm bones of a weightlifter to be thicker and heavier than those of a jogger? Because weight-bearing exercise helps to build bone mass. 13, the hormones PTH, calcitriol, and calcitonin. We said PTH and calcitriol raise calcium levels, and calcitonin lowers calcium levels. Osteopenia is a condition that is caused from inadequate ossification